All right, you guys, we're going to take notes today on thermal energy versus temperature or temperature versus thermal energy. And so these notes are interactive, and you guys have a version that you are going to be going back to and kind of typing in the answers as we go through this PowerPoint. So pause the video when I say to pause the video, type in your answers when I say to type in the answers, and let's get started. So we started off talking about the differences between different types of heat transfer, so conduction, convection, and radiation. And we know that heat transfer is heat is the transfer of thermal energy from hotter substances to colder substances. So what is thermal energy and what is temperature? What makes something hotter? What makes something colder? So the first thing that I want you guys to do is just in your own words, go onto your PowerPoint, pause the video, and try to define what you think temperature is. Okay, so after you've done that, I want you to predict which has a higher temperature. So does the ice cream or does the hot coffee have a higher temperature? So you're going to go onto yours, you're going to drag and drop your icons onto whatever you think is hotter or has a higher temperature. All right, so obviously we know that the coffee has the higher temperature and the ice cream has the lower temperature. And so on the next slide, what I would like for you guys to do is just tell me, was your prediction right or wrong? Okay, and what was your reasoning? So if you said that the coffee was higher than the temperature of the coffee was higher than the ice cream, why were you right or why were you wrong? And so temperature is, and so now you can pause the video, you can go over, you can kind of type this in and then come back. Temperature is the measure of the average kinetic energy of the particles of a substance. So when we take a temperature of something, we're actually measuring how fast the particles are moving. And if particles are moving faster, we know that they have a higher temperature. If they are moving slower, they have a lower temperature. And our example is that we use a thermometer to measure temperature. When particles are moving faster, they cause the liquid in the thermometer to move faster and they cause it to kind of go up in the little tube. If particles are moving slower, we see that the particles start to move slower. If the temperature is lower, we see the particles start to move slower. They start to condense, they start to go down the tube, and the thermometer level goes down. And so you guys are going to be typing that into your slide. All right. And now, what do we have for thermal energy? So now pause the video, go over to your notes, and in your own words, define what you think thermal energy is. And let's predict. So what has more thermal energy, an iceberg or a boiling pot of water? So go over to your notes and predict and come back. Okay. What we actually see is that the iceberg has more thermal energy than the pot of boiling water, which is interesting, right? So now on the next slide, I want you to tell me if you were right or if you were wrong and your reasoning behind that. So why did you think that you were right or why did you think that you were wrong? So what is thermal energy? So again, we're going to pause. You can kind of keep coming back and forth to type this into your notes. Thermal energy is the total energy of the particles in an object. The more particles a substance has at a given temperature, the more thermal energy it has. So it's the total energy of all of the moving particles in that substance. So if we have a bigger substance and we have more particles, there's going to be a higher total energy. It doesn't matter what the temperature is. If you have more particles, it equals more thermal energy. And so the example that we have here is that the iceberg obviously is much larger than the pot of boiling water. And so there are a lot more particles in the iceberg than there are the boiling water. Therefore, the thermal energy of the iceberg is much higher than the pot of boiling water. And we see that in this example, elephants and humans have the same body temperature, about 98 degrees Fahrenheit. However, the elephant will have much more thermal energy than the human because it has more particles. It's bigger. And you guys are going to type that into your notes here. So you can go back and pause and go over and type that into your notes. And let's watch. So now I want you to pause the video. You're going to go onto your slide, and there's a video that's on There's No Such Thing as Cold. It's about 5 minutes. So you can pause, go over there, watch the video, come back. All right, now that you've watched the video after, I want you to go through and I want you to write down 3 facts that you learned that you didn't know before. And I would like you to write full sentences in these text boxes here. Okay, and now we're going to practice using a cup of coffee as our example, or just coffee as our example. So I want you to predict which has a higher temperature. The coffee on the right that's at 60 degrees, or the coffee on the left that's at 20 degrees. So obviously, we know that the coffee with the 60-degree temperature is higher than the coffee with the 20-degree temperature. Okay. Now, of these two, which has more thermal energy? So we have a pot of coffee at 60.4 degrees Fahrenheit and a cup of coffee at 60.4 degrees Fahrenheit. So pause the video, go over and figure out which has more thermal energy. All right, and so yes, of course, the pot of coffee has more thermal energy. I'm messing up my pictures here. And the cup of coffee has less thermal energy. All right, and the reason why the pot of coffee has more thermal energy is because it has more particles. All right, so even though they're at the same temperature, because we have more particles, thermal energy is the total energy of the particles, or of the moving particles. So more particles, more thermal energy. All right, and now it's your turn. I want you to think of an example that's going to help you remember the difference between temperature and thermal energy. So give me an example of temperature in this box and give me an example of thermal energy in this box. If you can't think of anything on your own, feel free to look something up, be resourceful, and keep this as a resource that you can kind of come back to when we have like a test or something, to study and understand the difference between temperature and thermal energy.